Alrighty, hello everybody. We are going to work on chapter 13, section 4 today, which is about creating equations of lines. This is yet another section that is a review from Algebra 1, but it's a good one to use to kind of segue into the next, really the whole next unit that we're doing, but the rest of this unit for sure, and then also the next unit, because we're going to need to create equations of lines that make up the shapes that we're going to be talking about. So there are a few different forms of equations that you can make, and one of them that we haven't talked about yet this chapter, but you'll be familiar with, is point-slope form. And in point-slope form, that would imply that you've been given a slope, and that slope is going to be the letter m. So we'll say m is the slope, and you've been given a point, a coordinate point called x1, y1. And when you're making the equation in point-slope form, the formula is y minus y1 equals m, parentheses, x minus x1. You probably remember that. So we'll put the x1 and the y1 in the places where they go. We'll put the m in the place where it goes. And then we're done. This is a plug and chug formula where we don't really need to do any calculations. So we can take point-slope form and then turn it into slope-intercept form and standard form. It's sort of like the jumping off point, the starting point for how we're going to make equations and then turn them into something more useful and more elaborate for ourselves. So coming down here, we're going to start with this information. Write the equation of a line with a slope of 5, which passes through to -3. And we're going to go from point-slope form to slope-intercept form to standard form with this same information. We're going to start in point-slope form. So we're going to say, all right, that's going to be the form y minus y1. My y1 coordinate is -3, so y minus -3 equals m, my slope, which is 5, parentheses x minus x1, which is 2. So there's my point-slope form equation. Generally, we don't like to see a minus negative in there, so we can just change this. Y plus 3 equals 5, parentheses, x minus 2. And point-slope form keeps these parentheses. We're not going to distribute in there because this equation is written perfectly in point-slope form. Now to change it to slope-intercept form, that's where we're going to do some of the arithmetic and distribute. So we're going to take this function, we're going to put it up here. We're going to start with y plus 3 equals 5, parentheses, x minus 2. We want to turn it into slope-intercept form, which, as you remember, is y equals mx plus b. So our first order of business here is to distribute that 5. So we've got y plus 3 equals 5x minus 10. And then to turn it into our y equals, we will subtract 3 from each side, and we get y equals 5x minus 13. So in slope-intercept form, our equation is y equals 5x minus 13. But what if we want our equation in standard form? We're going to take our slope-intercept form equation, y equals 5x minus 13. We're going to remember that standard form is written in the form ax plus by equals c, and so that's what we're going to go for here. We want the x and the y to be on the same side. So we'll subtract 5x from each side, and we want it to go x then y, so we'll say -5x plus y equals -13. And of course, one of the rules for standard form is that our a value, the one in front of x, cannot be negative. So I'm going to take this whole equation and multiply by -1 to change my signs. So I get 5x minus y equals positive 13. And that's my same equation in standard form. So throughout the work today and the work on your worksheet, you're going to be asked for equations in different forms. Make sure you're paying attention to that so that you're giving the answer in the correct form that's being asked for. They're all equivalent, but we want to make sure that we're able to do any of the forms when we're asked to give them. So first of all, or I guess second of all, we want to talk about creating a line when we are given 2 points. So in order to make a line between 2 points, we first need to figure out the slope between those points. Once we do, we can use point-slope form to find the equation of that line. So we're going to find the slope. We know how to do that. So slope, we'll go y2 minus y1, so 15 minus 5 over x2 minus x1, -8 minus 2. That gives us 10 over -10, which simplifies to -1. So the slope is -1. Now, in order to put this into an equation, we're going to use the point slope form equation. And we're going to choose this slope. And we're going to choose one of these 2 points. You can choose whichever one you like. I usually like to choose the one without any negatives in it. So I'm going to take this point and I'm going to take this slope and I'm going to put it in point slope form. So y minus y1, which is 5, equals my slope of -1, parentheses, x minus x1, which is 2. So that's my line in point slope form, but this said to write a line in slope intercept form. So we're going to take it from point slope form to slope intercept form. So we'll distribute. We get y minus 5 equals -x plus 2. And then we'll turn this into a y equals mx plus b by adding 5 to both sides. And we get y equals -x plus 7. This should be something familiar to you from last year. So there's my line. It's in slope-intercept form, so I know that I've given it in the correct way the question was asking, and I'm finished. Down here, again, something you've done before, we're going to create parallel lines. So we are given some information about a line that already exists, and we want to make a line that is parallel to that one. So it says, what is the equation in slope-intercept form of a line which is parallel to y equals 1/2 x plus 4 and passes through -8, -3. Now remember from last section, if 2 lines are parallel, they have the same slope. So we look at the first equation and we say, well, what's the slope of this equation? It's written in slope-intercept form, so its slope is 1/2. So the slope of my line, the new slope, or the slope of the new line, is also going to be 1/2 because it needs to be the same slope. So now I have a new slope, and this line needs to pass through this point. Well, that gives me a point and a slope. I am able to make an equation in point slope form and then turn it into slope intercept form, the same way we did above here. So we'll start in point slope form. So y minus y1, which is -3, make sure you've got the minus negative, equals m, my slope of 1/2, parentheses x minus x1, that would be minus -8. And then we'll go through and simplify and turn this into slope-intercept form. So we'll change this to y plus 3 equals 1/2, parentheses x plus 8. Do our distributing, y plus 3 equals 1/2 x plus 4. And then we'll subtract 3 from each side. And so we get y equals 1/2 x plus 1. Nothing too crazy there. And if you graph both of these lines, you'll notice that since they have the same slope, they will be parallel to one another. Same idea applies when we're talking about equations of perpendicular lines. But for equations of perpendicular lines, we know that the slopes of those 2 lines are different. So it says write the equation in standard form of a line that contains 4, 7 and is perpendicular to 4x minus 2y equals 9. So the first thing I see here is that my line is written in standard form. In standard form, it's hard to see, or really, you're not able to immediately see what the slope of the line is. And we need to know this slope, because if we want to make a line that's perpendicular to it, we need to make a line with an opposite reciprocal slope to this line. So let's change this equation into slope-intercept form so we can see what the slope is. So we'll take this, we want to turn it into y equals mx plus b. So we'll subtract 4x from both sides, and we get -2y equals -4x plus 9. And then we want to divide both sides by -2 so we can get y on its own. And we get y equals positive 2x minus 4.5. We don't really need that y-intercept, we just need to know the slope. And the slope of this line is 2. Once we have that slope, we're going to then say, well, that's kind of like our old slope, because that's the slope of the original line. So I'm going to come over here and I'm going to say the old slope is 2. And since we're making perpendicular lines, the slope of the new line changes. It's not going to have a slope of 2. Its slope is going to be the opposite reciprocal of 2. So new slope here. This slope is going to be the opposite reciprocal of 2, which is -1/2. So we've got this new slope, and we have a point that we need to include on this line. So we're going to use point slope form. We're going to say y minus y1, which is 7, equals our slope, -1/2, parentheses x minus x1, which is 4. And it says, write the equation in standard form. So we've got to take this point slope form equation all the way to standard form. So we're going to say, okay, we will distribute y minus 7 equals, my pen is dying, -1/2 x, and then plus 2. So then we'll add 7 to both sides. We're going to turn it into slope-intercept form first. So we get y equals -1/2 x plus 9. And then we need to turn this into standard form as well. So we'll bring that up here. We will move the x value to the other side. Here, that way you can see this. So we'll add 1/2 x to both sides. And we get 1/2 x plus y equals 9. We're almost there. However, you might remember that in the rules for standard form, it says we can't have a fraction in standard form. Our coefficients have to be whole numbers. So we need to think about changing this 1/2 to a whole number. The easiest way to do that is to clear the fractions by multiplying by this denominator. So we're going to multiply everything by 2. Can't just multiply this fraction. We have to multiply everything in the equation in order to keep our equation balanced. So 2 times 1/2 gives us x. 2 times y, we've got plus 2y equals 18. So there is the equation in standard form. So go ahead and turn this over. We're going to apply this now to some more geometry, because the stuff you've seen right there was stuff that we've already done or you've already done in previous classes. So these are going to be some of the applications for this technology or for this technique. So we're going to create a line with a certain y-intercept or x-intercept. This one's pretty simple still, but I wanted you to see it because it might be something that doesn't come naturally to you. You might not be like, oh, that makes a lot of sense if you don't see it done. So write the equation in point slope form of a line with a slope of 4 and an x-intercept of -6. And the key here is to remember that x-intercepts and y-intercepts are coordinate points. The x-intercept of -6 represents the coordinate point -6, 0. Because if you make a dot at -6 on the xy axis, you're making that coordinate point. So we've really been given a point and a slope. It just was written a different way. So we're going to use point slope form. Y minus y1, which is 0, equals our slope of 4, parentheses, x minus x1, which is -6. And then we can clean that up a little bit. We don't need a -0. We can call that y equals, because -0 doesn't do anything. And here we've got 4 parentheses x plus 6, because minus negative is a plus. And we're done. That is our equation, because all it wanted there was point slope form. Here is where we get into triangles. So all of these are going to be related to this triangle diagram that's been given. So you've got point A, point B, and point C labeled here. So first of all, we're going to write the equation of a median of this triangle. So it says, what is the equation in slope-intercept form of the median CD? And if you'll remember, that tells us that our median is going to start at point C, which means it goes across our triangle this way. So point D is somewhere over here. So point D, because this is a median, is the exact midpoint between A and B, right? The median of this triangle is going to go from C to the exact midpoint. So we need to figure out where this midpoint is in order to find that. So we will use the midpoint formula for A and B. So we'll say MP, midpoint of A and B. We'll say that that's 2 plus -1. Ignore my cat. Over 2. And then the y-coordinate will be 5 plus 3 over 2. And we'll just figure that out there. So we can say that this is 2 plus -1 is -1/2 or -0.5. I'm going to use decimals because I'm going to be calculating with these. And then I've got 8 over 2, which is 4. So this point, which we can call point D, is -0.5, 4. So to make the equation of this line, you'll notice that we now have 2 points on this line, and we can make an equation from 2 points on the line. So we're going to do that first by finding the slope of this line, finding the slope between those 2 points. So let me write those 2 points over here. We're using negative 0.5 comma 4, and we're using 1 comma 1. So to find the slope in between these 2 points, we're going to say y2 minus y1, 1 minus negative 0.5, over x2 minus x, oops, I did that incorrectly, sorry. Y2 minus y1 would actually be 1 minus 4 over x2 minus x1, 1 minus negative 0.5. So this gives us negative 3 over 1.5. And if we divide that, negative 3 over 1.5, we get negative 2. So the slope of this line DC is negative 2. Once we find the slope, we can use the slope and either point to make a line in point slope form. So we can find the equation of this line. I'm going to use 0.11 because it's nice and it doesn't have a decimal. So I'll say point slope form, y minus y1, so 1, equals my slope, which is negative 2, parentheses x minus x1, so x minus 1. And there's my line in point slope form. But I want this line in slope intercept form, so I am going to keep going till I get a y equals mx plus b. So I'm going to distribute. So y minus 1 equals negative 2x plus 2. And then I'll just add this 1 to both sides, and I get y equals negative 2x plus 3. So that is the equation of this line I drew in here, DC. All right, coming back to the same triangle for the next example, we're going to find the equation of an altitude. It says, what is the equation in slope-intercept form of the altitude to BC? This is telling us where the altitude is, because there are 3 possible altitudes. We want to find the altitude to BC. So here's BC. The altitude to side BC will be the altitude that is perpendicular to BC going through the point opposite. So we've got to figure out where a line drawn from A would be perpendicular. So let me eyeball this real quick. So it's going to be something like this. Wherever this line is going to make a right angle, we want to find the slope of this line. Well, actually, we want to find the slope so that we can find the equation, because we can make an equation of this line. So what is the equation of the altitude in the triangle at right? So we have to find, first of all, the slope of BC, because we know the altitude to this line is going to be perpendicular, and it'll be an opposite reciprocal slope. So we're going to start by finding the slope of this line, because we can't really find this point. We're going to find the slope here. So we'll use BC, so that'll be negative 1, 3, and 1, 1. And we're finding the slope between those. So we'll say, I'll write that over here, slope of BC. So y2 minus y1, 1 minus 3, over x2 minus x1, 1 minus negative 1. That gives us negative 2 over 2, which gives us a slope of negative 1. So this altitude has a slope of negative 1. Okay? So, the BC rather has a slope of negative 1. We need to find the slope of the altitude. So we're going to find the slope, or the opposite reciprocal, of the slope we already found. The slope we already found was negative 1, and the perpendicular slope to negative 1 is just positive 1. The opposite reciprocal of negative 1 is positive 1. So we've got positive 1, we've got a slope. In order to create an equation, we need a slope and we need a point. Well, we know a point on the altitude because this line of the altitude goes through point A. So we can use the slope of 1 and the point of point A. So the point of 2, 5 to create this line. So we've got our point, we've got our slope. We're going to put it into point slope form. Y minus 5 equals 1, parentheses x minus 2. And we want to change that into slope-intercept form eventually. So we're going to come down here, distribute. Y minus 5 equals x minus 2. And then add 5 to both sides. And we get y equals x plus 3. There is our equation in slope-intercept form. And then finally, this is something we haven't talked about yet. There's another kind of line that goes through a triangle. There's the third kind of line that goes through a triangle. It's called the perpendicular bisector. And the perpendicular bisector is the line that is perpendicular to a side of its triangle at its midpoint. So bisector means midpoint, perpendicular means perpendicular. So in this case, it says of the perpendicular bisector of AC. So we're talking about side AC, and we're talking about a line that goes through the midpoint of AC and is perpendicular to it. So make a right angle here. And if I extend this line out, you'll notice that it doesn't go through point B. It doesn't go through a point. The perpendicular bisector is defined as just being through the midpoint and perpendicular. It doesn't have to go through another point on our triangle. So I'm going to come down here. We'll talk about what we're finding. We're finding the line that is perpendicular to side AC at its midpoint. Midpoint. So to find this, first we have to find, well, what is the midpoint of AC? That's going to help us out a lot. So we'll say MP, midpoint of AC, and we'll use the coordinates for AC, which are 2, 5, and 1, 1. So finding the midpoint, we'll say that's 2 plus 1 over 2, 5 plus 1 over 2, which gives us 3 over 2. I'm going to call that 1.5 since we might use calculations with it. And then we've got 6 over 2 here, which is 3. So the midpoint is 1.53. I also need to find the slope of this line, because if I want to find a line perpendicular to AC, I first need to find the slope of AC so I can find the opposite reciprocal. So let's find the slope of AC. I'll label these so that they make sense. So we'll find the slope of AC. So we'll say y2 minus y1, 1 minus 5, over x2 minus x1. So that's going to be 1 minus 2. That gives us negative 4 over negative 1, which gives us a slope of positive 4. So the line AC itself, that line of our triangle, that has a slope of positive 4. The line perpendicular is going to have the opposite reciprocal slope. So the new slope, or the perpendicular slope, is going to be the opposite reciprocal of 4, which is negative 1/4. So we'll take this slope, and we'll take this point, because this midpoint is a point on our line. So we've got this point, and we've got the slope of the line. We can figure out the equation of it. So we'll use point-slope form. So we'll say y minus y coordinate. You can't even see that. There we go. Y minus the y coordinate of 3 equals our slope of negative 1/4, parentheses x minus the x coordinate of 1.5. We want to change this into slope-intercept form here. So we'll go ahead and turn this. So we'll take that and distribute. Y minus 3 equals, I'm going to turn this into a decimal, negative 0.25x plus negative times negative, and then we've got 1/4 times 1.5, which is 0.375 as a decimal. And then we'll go ahead and add 3 to both sides, and we get y equals negative 0.25x plus 3.375. That's the equation of our perpendicular bisector in slope-intercept form. All right, I hope that this video answered any questions that you might have, but if you do have any questions, feel free to message me or post on the discussion board. Thank you very much, and have a great day.